Alright, so for number 1, in this one we have cosine cubed of 5t times sine of 5t. Little trick for these types of problems, similar to the ones we saw in the class starter. If we have sine and cosine in the same integral, and one of them is raised to a power, that one is going to be our u. So if we have sine and cosine, we have sine and cosine, and one of them is raised to a power, that one is our u. Because think about it, sine and cosine are pretty nice and interchangeable with u substitution because each one is basically kind of the derivative of the other with the exception of maybe a positive or negative. So if we have cosine cubed of 5t, remember that's the same as cosine of 5t, that whole thing cubed. So we can think of that as this whole function here raised to the third power, so this inside part can be set as our u. So that's what we're going to do here. U is cosine of 5t. And the nice thing then is that our du is going to be the derivative of that, which is going to incorporate sine. Derivative of cosine is negative sine of 5t, but then we have to remember to take the derivative of the inside, using the chain rule here, which is 5. So we get negative 5 sine of 5t dt for our u. So we know that cosine of 5t, that's going to become our u. Then we have to look at our du. We need to make sure everything's in place to be able to make the complete substitution. We have the sine of 5t and the dt. We're missing the negative 5. So we need to multiply the inside by negative 5, outside by negative 1/5. And now we have everything inside to replace that with du. We end up with negative 1/5 times the antiderivative of u cubed du, which is a much more manageable problem than what we started off with. All right, we can do the antiderivative of this. We add 1 to the exponent, so u to the 4th, and then divide by this new exponent. So divide by 4 or multiply by 1/4, we get negative 1 over 20 u to the 4th plus c. And then our final answer should be in terms of t, since that's what the problem started in terms of. So we end up with negative 1 over 20 times cosine to the 4th of 5t plus c. All right, so make sure you're not putting in the 4 next to the 5t. Remember the notation, we put it right next to the trig function for that exponent. Questions on that one? All right, how about number 2? What do you think is going to be our u for this problem? 1 minus cosine of 2x, right? We're taking the square root of that that's inside of another function, and generally for our u, we're looking for something inside of another function. So we're going to take the derivative of this. Derivative of 1 is just 0. Derivative of negative cosine is sine of 2x, but then we have to do the derivative of 2x also, using the chain rule again, which is 2. So 2 sine of x dx. I'm sorry, 2 sine of 2x dx. So now we want to check everything's in place. We know this is going to become u, and then we have the sine of 2x. We've got the dx. We're missing the 2. So we're going to multiply the inside by 2, outside by 1/2. Now we have everything we need for du. So we get 1/2 times the antiderivative of 1 over square root of u du. And all that green part turns into our du. We're left with just 1 on top, and then over square root of u. But before we do the antiderivative, we want to think of this as u to the negative 1/2. All right, to do the antiderivative, we want it to be in terms of u to a power in order to figure that out. So we're adding 1 to the exponent, we get u to the 1/2. Then we have to divide by this, or multiply by the reciprocal. So we're doing the 1/2 out in front. From here, then we're multiplying by 2, because we have to divide by this, or multiply by its reciprocal. So the 1/2 times 2 cancels out. We're just left with u to the 1/2 plus c, or we can write it as square root of 1 minus cosine of 2x plus c. If you wanted, you could also write 1 minus cosine of 2x, that whole quantity in parentheses, to the 1/2, or you can just use the square root.